Most hands-on pilot training occurs not in the air but on the ground. The classroom in which this instruction takes place is a flight simulator, a high-tech replica of the aircraft cockpit. Through the magic of sophisticated computer software, the simulator mimics the process and feel of flying the aircraft. The flight simulator can produce darkness or daylight, clear or stormy weather, or an emergency such as engine failure or a runway tire blowout. Simulators are modeled after specific aircraft, such as the Boeing 737. The simulator manufacturer buys the technical data from the aircraft manufacturer, so it can build a cockpit which is an exact replica in both look and feel. After assembling a steel frame and building the instructor station behind the cockpit, they mount a sound system beneath the cockpit. This enables crew communication and produces realistic aircraft and weather sounds. A computer-driven image generator produces the cockpit view on a large spherical mirror made of a thin polyester film. A vacuum pump sucks it flat and wrinkle-free. The image reflecting on the mirror creates the illusion of the infinite view pilots have in a real aircraft. The image generator doesn't send the visuals directly to the spherical mirror facing the pilots. A projector first shoots the image onto a flat rectangular mirror that reflects the image onto a front projection screen, that round part at the top. The image on the projection screen then reflects in the spherical mirror in front of the pilots. This diagram illustrates how the image travels. Technicians prepare the cockpit throttles, adjusting the lever tension to be identical to that of the real aircraft. Inside each throttle, they check the thrust reverser that pilots activate upon touchdown to reverse airflow and stop the plane. Next come the control panels, with all the buttons and switches to operate everything from the engines to the air conditioning to the lights. Next, the motion actuators, giant legs which move the cockpit. They attach to a concrete slab with jumbo bolts. Technicians attach conduits through which electrical cables and air hoses run to the actuators. The motion is electro-pneumatic, meaning that air assists the electric motor that moves the legs. To attach the actuators, technicians activate the brake inside each one. This enables the leg to stretch far enough to reach the base. After checking the alignment with this tool, they insert a pin. Then they test the movement of the entire apparatus. The test pilot runs the finished flight simulator through different maneuvers to ensure it performs perfectly. The image generator is run by highly sophisticated software. It knows the design of every airport in the world, enabling the instructor to conjure up any scenario imaginable. Takeoffs, landings, and taxiing at a specific airport, any weather conditions or runway hazards, or any unforeseen events such as a blackout that plunges the entire airport into darkness. Faking it doesn't get any more real than this. Today's books are mass-produced by automated equipment. But before the industry was mechanized, book pages were hand-bound. Their covers meticulously handcrafted one at a time by talented bookbinders. This skilled trade still exists, but is now a specialty service. Bookbinders are part artist, part restorer, because they craft new bindings, yet also repair originals. Before rebinding a book, the bookbinder has to unbind it. She uses a surgical scalpel to cut the strands of old binding thread. This separates the covers and the sections of assembled pages called signatures. Using a paper cutter, she trims the components just enough to make their edges neat and smooth. Then she positions the signatures in a vise sandwiched between cardboard for support. She draws lines across what will be the spine of the book. Then she carefully saws a groove in each line. The groove is just big enough to fit a piece of hemp binding cord. One at a time, she reconnects the signatures on a sewing frame. The frame has binding cords that correspond to the grooves she sawed into the signatures. She sews a linen thread horizontally, looping it around the cords. A chain stitch on each end links each signature to the neighboring one. When she's done, she coats the sewn area with glue. She then lays a thin cloth backing over the glue. Then closes the vise tightly to round the back and form joints into which the book's covers will fit. She perfects the joints using a hammer. Next, she weaves the binding's headband by wrapping threads around support sticks in a specific pattern. She does this on both the top and bottom of what will be the book's spine. Next, by folding and gluing pieces of paper, she constructs a tube the exact width and length of the spine. She glues the tube to the spine. Now for the book's front cover. She layers pieces of cardboard to create a design, then glues it onto a rectangular piece of leather. She presses the leather against the cardboard with a plastic tool called a bone folder. Next, she cuts a strip of thick paper the width of the book spine and glues small bands across it. Then she glues this onto the leather, right next to the cardboard. Using the bone folder again, she presses the leather down. After adding a second cardboard for the back cover, she glues and folds over the edges. Then she makes 2 swift incisions to remove a triangle of leather. This produces perfect corners every time. Next step, to embellish the cover and spine with gold embossed decorations and lettering. She lays down a sheet of genuine gold foil and hot stamps the design onto the surface. After attaching the bound pages with leather hinges that match the cover, the bookbinder applies the finishing touch, decorative paper on the inside covers. From such traditional styles to ultra-modern fish skin bindings, it's hard not to judge these books by their covers. From the greenhouse. When cultivating tomatoes indoors, producers can strictly control the growing conditions. so greenhouse tomatoes are more uniform in size, shape, and color than field-grown tomatoes. Some would argue that they taste better too. This company grows large cluster-type and smaller cocktail-sized tomatoes. It also produces a kit containing tomatoes, a pouch of Italian spices, and a bruschetta recipe. In this hydroponic greenhouse, the tomato plants grow in a substrate rather than soil. The substrate is a block of coconut shell fibers that retains and drains water very well. Greenhouse workers mix fertilizer primarily out of powdered iron and calcium nitrate. They dissolve these and additional chemicals in water, which they then dilute and store in tanks. Computerized fertilizer injectors shoot controlled amounts of the solution directly into the irrigation system water supply. A new tomato plant takes 30 to 55 days to blossom. Then another 8 weeks to produce fully ripened fruit. Each plant receives up to 1 gallon of fertilized water per day via an irrigation dripper. The irrigation system collects whatever the plant doesn't absorb, mixes it with fresh water, adjusts the fertilization, then refeeds it to the plants. The task of pollination is left to a resident colony of bumblebees. The plants grow at an astounding rate of 8 to 12 inches per week. To train them upright so they won't get tangled with neighboring plants, workers twist each one around a nylon cord every week. Tomato plants grow to a height of more than 36 feet. That's taller than the greenhouse, which is why once a week, workers lower the plants by 8 inches. The lowering process also lines them up at the same height, which makes harvesting much easier. The greenhouse temperature is 70 to 77 degrees Fahrenheit during the day and 54 to 61 degrees at night. Artificial lighting simulates 18-hour stretches of sunshine. Thanks to these controlled growing conditions, greenhouse tomato plants, unlike field plants, are in continuous bloom. Every week, a new cluster appears at the top of each plant, while a cluster at the bottom is ready for picking. In its 1-year lifetime, a tomato plant yields some 200 large tomatoes or 500 cocktail tomatoes. As conveyor belts move the tomatoes through the packaging area, workers separate the green ones from the ripe ones. Each shipping box must contain 11 pounds. Workers place the box on a tray scale and clusters of tomatoes on digital scales above it. A computer calculates which combination of clusters would total the target weight, then illuminates the light under those clusters to tell the packer which ones to put in the box. Once filled, the boxes pass through an automated labeling machine. A camera takes a photo of the configuration, then guides an applicator to slap a code sticker on every tomato. Besides selling bulk tomatoes in the bruschetta kit, this company packages cocktail tomatoes in 2 formats, loose and still on the vine, giving greenhouse tomato lovers a few tasty options. Windows. Not only can breaking glass cause injury and let winds enter and wreak destruction inside, but the difference between indoor and outdoor air pressure can cause the roof and walls to collapse. Roll-down shutters move vertically, whereas accordion shutters consist of two sections that move sideways. To make the accordion style, they cut stacks of blades to the height of the customer's window. Blades are interlocking aluminum strips manufactured for the shutter factory by a supplier. Workers assemble enough to build two shutter sections that cover the width of the window. These two sections are called vertical stacks. They punch holes in the last blade of each stack for a locking mechanism. These two blades are called center mates because they overlap at the center of the window and lock together. They slide each center mate into its respective vertical stack. The next step is attaching nylon bushings and wheels, which ride in horizontal tracks installed at the top and bottom of the window opening. Each center mate has vertical locking pins. Activated by a thumb screw, these pins slide through a hole in the track to lock the shutter open or closed. The horizontal slats of a roll-down shutter are made of the same material as the accordion shutter's vertical blades. After cutting the slats to the width of the customer's window, workers assemble enough to cover the window's height. These slats have a different type of interlock than the accordion shutter blades, but they connect the same way. The tongue edge of one blade slides into the groove edge of the next. Nylon locks prevent the slats from disconnecting. After hammering the locks into place, they crimp the edge of each slat. The connected slats will later be coiled around a motorized tube inside the shutter's aluminum housing. A technician installs a ball bearing assembly in one side of that housing. Then a safety plate to prevent the slat roll from shifting sideways. On the other side, they install a plate with protruding screws, to which they mount the motor. Next, they install a safety plate to prevent the slats from catching on the motor's power cord. On each end of the motor, they fit spacers. Then, over the motor, a roller tube. They insert a connecting shaft which attaches the tube to the ball bearing assembly on the other side. All these steps assemble a motorized axle around which the roll of slats will wrap. Once a quality control check ensures it operates flawlessly, they close off the back of the housing with an aluminum cover. Working from the front of the housing, they rivet plastic rings along the length of the tube. These help muffle the noise the slats make as they roll and unroll. Workers rivet slat hangers to the roller tube. They slide the first slat onto these hangers. Then they slide the slat roll onto that first slat. The slat edges run in vertical side rails which installers mount in the window opening. Now for a last round of quality control testing. Workers lift and lower the shutter in manual mode as well as by remote control. When everything works perfectly, the shutters are subjected to one final test to ensure they can handle everything that a hurricane can muster.